Welcome to the Albuquerque Journal's Tech Outlook podcast. CNM is truly one college with infinite possibilities in tech and data sciences. CNM offers programs where everyone can learn about software, apps, or how to build websites. You can also choose from AI programs and machine learning, the Internet of Things, and so much more. CNM, one college, infinite possibilities, and the proud sponsor of the Tech Outlook podcasts.
Hi, welcome back to the Tech Outlook podcast. I'm Ryan Botel with the Albuquerque Journal, and my guest here today is Darren Raspa, who is the historian for the Air Force Research Laboratory. Darren, thanks for joining us today.
Happy to be here, Ryan.
Now, can you just introduce yourself and tell us a little bit about how you ended up working at AFRL?
Sure. So, like Ryan mentioned, I'm Darren Raspa. I'm the historian for our local site of AFRL. This is the Phillips Research Site of the Air Force Research Laboratory, which consists of space vehicles and directed energy technology directorates. And so my path to AFRL was somewhat circuitous, right? I started out in school in LA and ended up coming out to the University of New Mexico to complete my doctoral education. And during my last year's study at UNM, I found an internship with the history office on base at the Air Force Research Laboratory. I thought, well, that is unique. I missed the idea of public service. I used to work on an emergency ambulance with LA County Fire out in LA, and it had been some time since I'd kind of given back in some capacity. And so I thought that would be a great way to combine both my historical skills and public service. Mm-hmm. So I applied for the internship, came on base, shadowed the previous historian for about a year, and then took over in 2017 as the historian.
So you were a PhD level historian and then ended up at the base at AFRL.
That's correct.
Okay. And now let's talk a little bit about AFRL in New Mexico. So the Air Force Research Laboratory is bigger than just here in New Mexico. There's multiple directorates, and then two of those directorates are here.
That's correct. So we have two of about 9 or 10 directorates, depending on how you define a directorate, in the Air Force Research Laboratory and the Office of Scientific Research in Washington, D.C., and we're spread across the country, and we have sites around the world as well, research sites. So this is just two of a larger unified research lab that encompasses both the Air Force and, in our case here in New Mexico, which is really cool, the Space Force. So our Space Vehicles group is all Space Force, all USSF personnel. And our directed energy group is mixed Space Force and Air Force personnel. It's very cool stuff.
Okay, so there's the two here are Space Vehicles Directorate and Directed Energy.
That's correct. So spaceships and lasers. It doesn't get cooler than that.
Okay, yeah. So tell us a little bit about what spaceships and lasers means and what work you're doing at Kirtland Air Force Base.
So the current mission for Space Vehicles and Directed Energy, on the space side, they're doing research and development in space communications, in making our spacecraft smaller. They're doing research in solar cell technology, deployable solar cell technology. They're doing research and development in space weather, quantum, you name it. If it's related to space and domain awareness of the space environment, we're doing it here on Kirtland Air Force Base with Space Vehicles. Now, on the directed energy side of the house, if it's related to lasers, microwave research, things like that, optics research, improving how we see space and how we see our own environment, then that's what directed energy is focusing on. And both of these two directorates, they work together in tangent and independently as well with the larger services.
Okay. Can you give us some of the history? I mean, why are they here in Albuquerque and not at another base somewhere else?
Yeah, well, it's a long story, right? I hope we have a lot of time. So I always say that the story of space in New Mexico starts thousands of years ago, right? I always take it back to Chaco Canyon because that's where you see the sun dagger and you see ancient peoples who lived here hundreds and hundreds and hundreds of years ago analyzing the heavens using the technology they had available. But what really starts to bring modern day researchers and specifically Air Force researchers out to New Mexico, once again, is space. It's actual physical space.
Okay.
Dr. Robert Goddard, who developed the first liquid propelled rocket in the 1920s, he's in Massachusetts, and there's only so much space in Massachusetts. It's already very built up in the 1920s, and you realize he has to get more space to launch his rockets higher and higher. So he comes out here to New Mexico in the 1930s, is able to refine his technology, which is then adopted into V2 rocket technology, which after World War II, we start to test out here in New Mexico as well because of that space. So how the lab ends up here, if that's the question, is it starts in Massachusetts in 1945, the Cambridge Research Lab, and their whole job is to analyze the atmosphere, the near space environment. We knew that after World War II, we were looking to space already, and we were looking to solve the problem of space. How do we get there? How do we stay there? How do we get there safely and stay there safely? We had a knowledge of the upper atmosphere, but we didn't really have a detailed survey of what that environment looked like. And if we were going to send our spacecraft, and more importantly, our people up there, we had to make sure that we knew exactly what was going on. And so we launched from the Cambridge lab a series of weather balloons. We would launch a series of rockets. We launched rockets from ships. We launched from planes, but we needed somewhere to launch. And so the Cambridge lab more and more would come out to New Mexico to do a lot of that testing for our high altitude balloon programs. And through that process, the lab mapped the entire jet stream of the continental United States. There was an intense level of knowledge that was gained from what was defense research that was then applied to the larger community that kind of benefited the nation and technology overall for the nation and the world. And so as far as our closest iteration of what the lab was on site was the Special Weapons Command, and that's a nuclear group, right? So you'll see this kind of relationship between nuclear and space, and I'll tell you why there's that relationship here in a minute. So the Special Weapons Command, they stand up in 1949, same time as Dr. Zacharias' Z Division of the Sandia Corporation in 1949. We share a 75th anniversary this year with our friends on the other side of the base at Sandia. And the Special Weapons Command is coordinating all these nuclear efforts that are going on in New Mexico, from Los Alamos to Sandia, and what the Air Force is doing to facilitate all of that. But we quickly see that we need more research and development in the nuclear area, figuring out what the nuclear environment is, what the radiative environment is of our upper atmosphere normally, so that if there's a huge spike in radiation in the atmosphere, we know, something got blown up, right? And that happens in 1949 when the Soviets detonate their first thermonuclear device.
Okay.
And so in 1952, the Special Weapons Command becomes a Special Weapons Center. But then in 1963, Kennedy says, well, maybe we shouldn't be blowing up so many nukes in the atmosphere and near the space environment and in the ocean. So he issues the Limited Test Ban Treaty. And so our group here in New Mexico says, well, we have to get better at analyzing the nuclear environment without actually detonating items. We have to get smarter. We have to get more agile and resilient. And so they start to develop electromagnetic pulse technology. So, Ryan, what an EMP is that's what's generated when a bomb is detonated, right? A nuclear bomb is detonated. And that's what an EMP can do is it can damage electrical systems, it can harm individuals. And so we figure out a way that we can recreate that type of energy synthetically without blowing anything up. And so we develop a whole series of test stands where we can drive aircraft onto on these facilities, kind of radiate them with EMP pulses to make sure that they're actually safe for people to fly if there was a case of a nuclear incident. And where space comes in is, well, a nuclear environment is very similar. A radiated nuclear environment, man-made, unfortunately, is similar to the space environment. Space is very radiated, right? Without the protection of the atmosphere, the sun's rays and all of the components that come off of the sun are horribly deadly, right? And damaging to our spacecraft. And so in order to make sure our spacecraft are safe and our aircraft are safe, you see kind of this melding of space technology and directed energy technology. So you see the stand-up of the Space Technology Center here in the 1980s during the Star Wars era, where we're starting to refine computer chips, make everything smaller, more compact. We all do work on the taxpayer dime, so we always want to look to saving the taxpayer money, right? So making things smaller, more efficient. It's expensive to get to space. It's hard to get to space still. And so if you're making a technology smaller, then you're going to be saving taxpayer dollars as well. And so after Space Technology Center, you see the Phillips Lab arise, and it's one of these 4 super labs that arises across the nation. Some of us are studying space, directed energy. Some of us are studying armaments, kinetic weapons. Some of us are studying propulsion. we're studying various facets of Air Force technology. And already we were studying directed energy and space-related technology during this early period. And so then in 1997, that's when you see finally the merging of all these super labs doing all these amazing, cool things technologically into one Air Force research lab. And so we've been one lab since 1997.
Okay. Fascinating. So there is this connection, this link that you're making between nuclear technology, space, directed energy. Mm-hmm. There's threads, there's links between those.
That's correct.
Okay.
Yeah.
And so the Air Force Research Lab, we were talking, you gave us a lot of history. So it originates out of Cambridge, and they're wanting space research.
Correct.
And they pick New Mexico because of like the missile range that there was here? What gave that the space?
Well, they picked New Mexico literally for its physical space, right? Yeah. There were just large areas of land that were not inhabited by very many people, and there was a lot of space to do a lot of these tests that involved rockets and balloons. And so you needed large unpopulated areas that you could test these items, mm-hmm. right? And also having the nuclear effort here, having the Los Alamos labs here, having Sandia here, that also brought us out here because this quickly became New Mexico became the center of space and nuclear simultaneously in the 1940s, kind of because of the Manhattan Project. And so that starts to coalesce research and development in defense in the New Mexico area.
Okay. Now, kind of a simple question, but people might not know. Tell us what directed energy is.
So directed energy is non-kinetic energy, right? So that is kinetic energy. That's me taking my object, that being my hand, and knocking on the table. That's mm-hmm. connected energy. Directed energy would be if I hold my hand near this water bottle and the heat that's radiating off it starts to warm the water. That's directed energy. That's mm-hmm. non-kinetic energy. And so they're working in laser, plasma, microwaves, pretty much technology where the energy is somewhat unseen, right?
Yeah. But people know what a laser looks like, and a laser is directed energy, right?
It is. It is indeed. Yeah.
And now, why does the Air Force want to be a world leader in directed energy? Well,
it's the Air Force primarily, and its number one customer is the warfighter, mm-hmm. The Air Force and the other services as well, the Navy Research Lab, Army, and so on. They develop technology to assist the warfighter, to make sure that the warfighter's mission is accomplished succinctly and safely for that individual. Our job is to make sure that job is performed by the warfighter well and safely, right? And so mm-hmm. we are the research and development angle. So we have a certain mission that the Secretary of the Air Force comes to us with, and we research the problems around that. We go to industry as our partner in helping us develop that technology and have a kind of a symbiosis between the government and industry to really assist the warfighter. And if a technology assists the warfighter and also happens to be commercially successful and applicable, kind of like GPS, cell phones, most mm-hmm. modern technology you see that really had defense origins. If you see a commercial success there, well, then that shows the Defense Department, shows AFRL that, okay, this is a reliable technology that not only the warfighter can rely on, the American people can rely on it, and this is something we can trust, right? So you see that kind of symbiosis between industry and government going back to the Wright brothers.
Okay, interesting.
Yeah.
And is there this business ecosystem in Albuquerque that partners from AFRL to industry in Albuquerque? Can you kind of tell us just how the business relationships are?
Oh, yeah, absolutely, Ryan. We work with a number of local industry here, Blue Halo, Red Wire, Northrop Grumman. The Max Q facility that's being built, it's a mixed-use facility right there on Gibson between Carlisle and San Mateo. Mm-hmm. That's designed as an area specifically for our industry partners to build. Right now, only NG, Northrop Grumman, occupies the space right now, and they do work with us quite a bit on some of our programs. But that's an open space. I mean, as far as an arena that industry can make headway in is starting to purchase that land, starting to lease some of that land space that I believe when I was driving by today, it's still open, and it's available for industry locally and abroad to start making a footprint here in New Mexico, because it won't be long before that whole 90 acres, I believe it is full. And so, AFRL, we see ourselves as part of a larger Space Valley coalition that we're a member of, which is kind of a partnering of universities. It's a partnering of local commercial interests and startups because we're all part of the same missions, right? Industry wants to make a reliable product that's going to make dividends, and the military wants a reliable product that's going to help save lives for the military. And so it's a symbiosis, and a lot of that research happens both at the lab environment and at academic lab environment. We have a unique place here in New Mexico where we have so many world-class universities within a few miles of each other, and so many world-class aerospace firms, and the government labs, Los Alamos, Sandia, Air Force Research Laboratory, New Mexico State, New Mexico Tech, University of New Mexico, all of these groups combining to create this synergy that's really unlike anywhere else I've ever seen.
Okay. Well, that's exciting to hear. How do people get into this level of field? Like, do you need a PhD to get into the space industry?
You don't. I mean, what that is a big misconception, actually, Ryan. In my job as a historian, I also engage in a lot of outreach, a lot of education outreach. I'm also their STEM coordinator for the K through 12 education programs. And so what part of my mission there is to inform not only school kids, but the larger public, students in high school, students in college, people who aren't even going to school, that there's jobs that exist for them in space vehicles, in directed energy, or not even that, that exist in aerospace for them, right? We don't necessarily need PhD level scientists doing everything, right? I mean, there's the famous line, I believe it was from General Groves, that Dr. Oppenheimer, leader of the Manhattan Project, couldn't run a hamburger stand. We don't need individuals that are off in theory all the time. We need hands-on individuals. We need builders. We need artists. A lot of people don't realize that. We need graphic designers, people who can visualize a system or of systems and think outside the box. People who know how to use different types of equipment, who know how to 3D print different types of equipment, or know how what types of instruments you would need to solve a specific problem. All levels of experience. Internships. That's the key, Ryan. That will get you, if you don't really have a background. I didn't have a background in the military or government before I came to AFRL, but it was the internship that gave me that experience into that world. Allowed me to meet the individuals, make those relationships, make the communication with partners I wouldn't have known before, and then kind of go on the track that I am today. So I strongly encourage folks to look at some of our internship programs, our AFRL Summer Scholar Program. I'm pleased to say I have one of my scholars with us today who's with us, and he's from the University of New Mexico. He just recently graduated, but that's extremely important. That's how you can kind of get in. But no, you absolutely do not have a PhD to make it in this world. Yeah. And we met in an AFRL event at the Civic Center with 1,000 fifth graders. Yeah. So what is it? Why does AFRL reach out to school children? How does that help the mission that you're trying to? Yeah. So, well, where we come from and where I come from is that a population that has STEM skills, science, technology, engineering, math, and art. I'm the STEAM coordinator as well. I'm always making the case for artists. A populace that has those kind of building blocks, they can do anything, right? And artists with a STEM knowledge of engineering and math, they have a whole new set of tools and whole new set of skills that they can use in any number of fields. And so what we're doing is we're kind of responding to STEM education that we see around the world. You see a lot of STEM education going on globally, and the United States, we did have some catching up to do, and I think that we have caught up, and that we're now we're advancing beyond near peer adversary countries in that arena, because our mission is to educate the population. An educated population is a strong population, really. And so that's where a lot of our education programs stem from. Great. Even if they don't end up in the government at all, fifth graders learning how to fly a rocket will be applicable, and if at the very least is very cool in some of the other programs that we run.
And how do you kind of, I mean, the Air Force Research Lab, some of this is making weapons was what the goal was, and then the technology needed for the weapon turns into something entirely differently. Is that?
Yeah, I mean, to a certain extent. So you have two arenas, right? You have transitioning technology and transferring technology. So what the first job of AFRL and other government labs to do, military labs to do, is to transition our technology to the warfighter, as I mentioned, to transition our technology to assist for defense purposes in some capacity. For example, situational awareness on a battlefield, like the first thing you have to do in any kind of engagement, seeing literally over the hill what the next individual over there that's throwing things at you is doing. That's where you see the first reconnaissance balloons. So you need to develop that first, right? And so once you get that technology refined and it's tested in an extreme environment like the field of battle, then you know that, okay, this is technology that's actually pretty helpful to other people, right? GPS technology, which the Defense Department developed, everybody uses that. I use that to get here today, Ryan, solar technology that's on most businesses now, fuel-efficient technology. All of that technology was first developed, certainly, for a defense purpose, but has transferred, as they say, to the academic world and thus to the common civilian public, just average people like you and me.
Yeah. Darren, when did you know you were going to do what you do?
Well, that's a good question. Well, on the ambulance, they used to call me the professor because between calls, I would always sit there with a history book in my hand. And so I always knew that I wanted to do something related to history. I thought I love to read history, and I thought, well, if I'm going to read history, I want to write history, right? And I think that if I want to write history, I should be the most qualified. So I went back to school. I got all the degrees you could get because I wanted to be the most qualified. Yeah, but
so you loved history, so you wanted to be a historian, and you went down that path, and then by fortune of an internship, you stumbled on the Air Force Research Laboratory.
So I was on the track, like many other grad students, with PhDs in hand, to adjunct at universities and things like that. But I saw this opening at AFRL as a potential to actually do that history, right? I have such an amazing job. I collect these artifacts. I collect directed energy and space vehicle artifacts. I house the artifacts. I maintain the artifacts. I collect these documents. I engage in interviews with Nobel Prize winning scientists and engineers all the time. I am given a level of knowledge of the space and directed energy environment and the modern science and technology environment of this nation. I'm doing things I never thought I would be doing, right?
Sure.
And it's just so exciting. It's so unique as a historian to actually use that degree every day, right? Professors in the classroom, certainly they use their degree in one capacity or another in their research, but being actively engaged in retaining the record of what we're doing now so that we can have tools for future use. That's incredibly rewarding, feeling really, really valued for my historical skill set on a daily basis is really incredible.
Yeah, I mean, you basically get to go in and tell the story of these brilliant engineers and science and math people and to tell that history and what it means to New Mexico.
It's a true privilege.
Yeah. What is the impact of AFRL? To kind of close us out, the work that you do and you see, what effect does that have on Albuquerque, just the economy and the community in general?
Right. Well, it's definitely improves the economy, right? I mean, we're drawing in aerospace companies from around the world, from around the country. We're drawing in individuals who are entrepreneurial, who have an entrepreneurial spirit, who may come out here for that space environment, but get engaged in commerce, in restaurant business, and something else, right? It's just kind of, there's a air of excitement in New Mexico that I would imagine was similar to the 1920s and 30s when air travel was picking up, and really New Mexico and Albuquerque started to take off with air travel, there's a feeling that there's still so many possibilities here in the state because of what the Air Force Research Lab has established as far as being the cutting edge lab for aerospace technologies in the state. And I think that does everything positive for the state, for sure.
Yeah. Well, Darren, thank you so much for coming in here and doing what you do and then getting to tell us some of that history. That was fascinating.
It's a pleasure to be here, Ryan. Thank you.
All right. Thank you much.